Solid Part 2. Defects in a solid. When we talk about crystalline solids, we say they have a definite structure. They have long-term arrangement of their molecules. This means that they have repeated arrangement of a unit cell to form a space lattice structure. So the arrangement of molecules, in the long run, will remain the same. Point defects. When the deviation occurs around an atom/particle, it is a point defect. It could be due to displacement, an extra particle, or a missing particle. Line defects. When there is an abnormality in the arrangement of an entire row, then it is a line defect. Stoichiometric defects. Stoichiometric compounds are those who maintain their stoichiometry. That means they maintain their ratios of cations and anions as indicated by their chemical formula. Vacancy defect. Here the lattice site is simply vacant, which means there is a missing particle. In a perfect crystal, there would not be this vacancy. This defect will lead to a reduced density of the solid. Some surrounding particle may move to fill in the gap, but the vacancy will only shift in the opposite direction. Also, the solid structure of the crystal will ensure that the particles surrounding the vacant spot do not collapse. Interstitial defect. There is an unoccupied space at the very center of the cube structure of the solid. When the 8 spheres of a unit cell meet at the center, they leave a little space, the interstitial site. Sometimes another particle will occupy this space. This is what we call an interstitial defect. Schottky defect. In this defect, more than one particle is missing. But the number of cations missing is equal to the number of anions missing. So the electrical composition remains the same. Frankl defects. When a cation is missing from its normal position and has instead occupied an interstitial site, it is a Frankl defect. Here the electrical neutrality will be unaffected. Also, it is usually cations that cause this defect, since they can easily fit in the interstitial site due to their small and compact size.